We have a multiple choice quiz with 10 questions. Each of them has 4 choices, and the student forgot to study and is guessing on every question. We want to know the probability that the student gets 9 or more correct. If the student is guessing on each question, we could think of each question as being a trial, and the probability of getting a question right stays the same as 1 out of 4. We could also think of these questions as being independent since the student is guessing on every question. So this is an example of a binomial distribution where the number of trials we have is n equal to 10, and the probability of success is equal to 1/4 because we have 4 choices, or we could write that as 0.25. And our random variable x is going to be the number of correct questions, where we think of getting a question right as being a success. So what we want is the probability that x is greater than or equal to 9, which we need to find then the probability of getting 9 correct, plus the probability of getting 10 correct. So if we plug the values into our binomial formula, we will get 10 choose 9 times 0.25 to the 9 times 1 minus 0.25 to the 10 minus 9. For the probability of 10 correct, we'll have 10 choose 10 times 0.25 to the 10 times 1 minus 0.25 to the 10 minus 10. So let's write what these combinations are. 10 factorial over 9 factorial times 1 factorial. We've got times 0.25 to the 9, and then here we've got 0.75 just to the first power. 10 choose 10 is 10 factorial over 10 factorial times 0 factorial. We've got times 0.25 to the 10, and this last term is 0.75 to the 0. And if you raise anything to the 0 power, that's just 1, so we'll leave that term off. So this turns out to be 10 times 0.25 to the 9 times 0.75 plus this quantity is equal to 1. 0 factorial is by definition 1, so we have 10 factorial over 10 factorial, which is just 1. So we'll drop that off and we're left with 0.25 to the power of 10. So this first probability is a very small probability, and what we have for that one is 0.0000286. 0.25 to the 10 is even smaller, and that one is 0.000000. So we have 6 zeros, and then trailing off with a 9/5. So if we add together, we get a total probability, which is still very small, of 0.0000296. So the chances of getting 9 or 10 correct, if guessing, is very low.